All right, in part 2 of the skier question, we actually want to go ahead and solve this differential equation. So let me just grab this guy here. Actually, just delete the whoops. Ooh. And now we're going to go to a new page, and we're going to continue the solution. All right, so that's what we want to solve. So here we go. The first thing we're going to do is we're going to actually do a little rearranging of the equation. So I'm going to write dv dt equals g sine theta. Actually, mdv dt equals g sine theta minus bv m. All right, so I'm not talking properly. I'm just writing stuff down. Let me try this again. So what we want to do is we want to get this thing solvable. So that means I'm going to get dv over mg sine theta minus bv equals dt over m. And now I'm going to do a substitution. I'm going to do u equals mg sine theta minus bv. And I'm going to end up getting du equals negative b dv. Again, if you are in Calc AB, this is good enough. And then you're going to end up getting here negative du over b equals dv. So now what we end up getting is that negative du over b times 1 over u equals dt over m. And so I'm going to end up getting du over u equals negative b dt over m. And I can integrate both sides now. And when I go ahead and do that, let me just integrate this out. I'm going to end up getting natural log of u equals negative bt over m plus c. Now the rule that I have here is that when time is 0, v is 0, and what that means is that u, which is mg sine theta minus b v, is b times 0, and that means u of 0 is going to be mg sine theta. So I'm going to end up getting that the natural log of u equals negative bt over m. Sorry, let me try that again. I'm going to end up getting that negative ln of mg sine theta equals c. So what I end up getting for my expression here is ln of mg sine theta minus bv all over mg sine theta equals negative bt over m. Your job is to actually prove that all this happens, and the final expression you're going to get for v as a function of time is mg sine theta over b times 1 minus e to the negative bt over m. That's going to be your velocity as a function of time. So that's part D done rather quickly because I've done this a few times. And then we'll finish up the problem in the last. Actually, you know what? We'll just do it now. So you can pause and take a little break. But it turns out part E of this video, we want to know a graph of the acceleration versus time. And the way that's going to work is we're going to end up getting, well, mg sine theta minus bv equals ma. So that means here a is going to have to end up leveling off to 0, and it's going to have to end up starting off at g sine theta, and then it's going to end up exponentially decaying to, let's say, g sine theta is here, and then it actually ends up, yeah, this is how to write it, ends up exponentially decaying from g sine theta to 0. That's supposed to be exponential. So that should be it for all the problems you're responsible for on your exam.